Okay, so day 2, solving exponential equations. What is the overall goal that we're trying to do? Like we have, there are steps involved in these, and there are like minor steps, but then there are major steps. What's our first major step? This is something you really want to have a good handle of and have in your head. Okay, when I'm solving something like this, this is the first thing that I have to do.
Make sure the base is the same.
Get the bases to be the same, exactly right. Okay, so I look at the base on the left side is 2, the base on the right side is 4. How can I rewrite one of them or both of them to have the same base?
2, 3x equals 2 squared.
Good. So this is a lot like the ones we were doing yesterday. Like I said, I can rewrite 4 as a power of 2. And what's the next major step that you have to know? This is something that, you know, is, I think, obvious when it's pointed out to you and you start to get used to it quickly. But it's not necessarily something that you would come up with on your own. It's not necessarily something that you could figure out on your own. After the next step, but we have a step before that. If the bases are the same, then the exponents are the same. So that's what you meant, right? Then we divide by 3.
Yeah, I was going to say divide by 2 and then it's
We're not dividing. Okay, that's fair. We haven't really talked about it. We're not really doing an operation here. So it's not that we're dividing. We're making, this is the reason why we use the therefore statement. That symbol that means therefore, those 3 dots, is because we're not really doing an operation. We're making a logical conclusion that if the bases are the same and there's no other junk, then the exponents have to be the same. So we're kind of just using logic. There is an operation, but we don't learn about it in this course. It's in a different course, okay? But even in the other course, in a case like this, you wouldn't use it. You would just do it this way. So we're just saying that if the bases are the same, the exponents have to be the same. So I make that statement, and then divide by 2, divide by 3, and then find your answer. And you can absolutely 2 to the exponent of 3 times 2 over 3. Depending on your calculator, you're going to need brackets. You're going to need to type it in a different way. But if you're using one of these where you can show fractions and stuff, I mean, you can do a quick check, right? And see that it's the right answer. Always a good idea. Because what could be a common mistake? Somebody might say 3 over 2. Just get it upside down. And if you punch that in, you're like, whoop, that's not 4. And you can go back and find that mistake and say, oh yeah, right, whoops. I did it backwards. This one's a little bit different. We didn't do one quite like this yesterday. One thing that's nice about math is the rules are rules. They always apply. There aren't exceptions. Sometimes it feels like there are exceptions. Sometimes there are better ways of doing things, but it's not an exception. It's just about being efficient. But there aren't exceptions to rules. So, as we just talked about, our first goal is to rewrite both sides with the same base. So if the base is 3, how do I rewrite the other side with base 3? It might look like you can't, but you can. Anybody? 3 to the something is 1. 0. Remember talking about that? Anything to the exponent of 0 equals 1. This will not come up a lot. There might be one on the quiz that looks like this. You know, it probably will only be 1 mark. But it is one of these little tricky ones where it looks like it's not going to work, but it's always just 0. Okay, so therefore, x plus 1 equals 0. We still equate the exponents. In other words, set the exponents to equal each other. And then what do we do? Move the 1 over. 0 minus 1 is negative 1. So that's our answer. Three to the negative 1 plus 1. Negative 1 plus 1 is 0. 3 to the 0 is 1. So that'll work. Again, you could punch it into your calculator, but if you can do that mental math, you can just maybe check it quickly and convince yourself that it's the right answer. Okay, again, this is similar to the ones we were doing yesterday, very similar. In fact, it might have been exactly one of the ones that was in the lesson yesterday, so it's just kind of, or in the practice, it might have come up before. The first step is rewrite both sides with the same base. So what base can you write them in? Can you rewrite 27 as 9 to the something?
3 to the 3.
You can rewrite 27 as 3 to the something, and you can rewrite 9 as 3 to the something. So that's the base that we're going to go with. But your thinking might be like, can I rewrite 27 as 9 to the something? I mean, the answer is yes, but not easily. It's a fraction, and that's not the way you want to do it. Okay, so in other words, I'm going to say no. You know, rewriting 27 as 9 to the something is not going to be easy. But I can rewrite them both as 3 to the something. 27 is 3 to the 3. 9 is 3 to the
2.
Okay. So that means this is 3 to the 2x because I multiply powers. So you could jump straight to the answer. We're going to start streamlining this. This is up to you. See what I did there? Like 2 times x. I mean, I can do that and say that it's equal to 3. But if you want to include, this is what we were doing yesterday. We were showing an extra step where we recognize that a power of a power is multiplying the exponents. So 2 times x is 2x. But if you're comfortable, you can start skipping that step. And what I've said all along is skipping steps is fine as long as it's not causing you to make mistakes, as long as you're comfortable. But if you start making mistakes, then you gotta reflect and recognize like, maybe I should go back and show that step because I'm trying to do too much at once. Divide both sides by 2. X is 3 over 2. So we can't rewrite 2 because it's already sort of the smallest version of things. So on a question like this, you're going to assume that you can rewrite 512 as a power of 2. Anybody know off the top of their head what it is? Or what would be your guess? Don't check it yet. Wild guess. 7. Great guess. It's actually not right, but it's really, 5 to the 7, whoops. 2 to the 7. It's close. So then I'm going to try 2 to the 8. Then I'm going to try 2 to the 9. And then we have it. So that's how that process works. We didn't do quite as big a number, I don't think, yesterday. Not in the same kind of context. But that's the way it's supposed to happen, is you're like, I don't know. And I'm going to guess that the thought process is, well, it's not 4, it's not 5, because I kind of know those ones. I think it's probably not 6, so I'm going to go a little bit bigger and just start with 7. And what did that take me? 5 seconds to then try the other 2 until we got it? Like, it's not that time consuming if you can make a good guess to start with, and then you try a couple more. So 2 to the x over 2. Remember, you can do this in one step, but I'm going to show it in 2, where I'm just going to keep it in the denominator. And how do I move it up to be 2 to the something? Because that's what we have to get eventually. Very good. -9, right? -9. If you think you can do all that in one step. Which for some people it feels like, yeah, that's not hard if you're comfortable with it. But the careful way of doing it is just thinking about what 512 is. It's 2 to the 9, and then dealing with the negative, right? Okay, now I have 2 to the something equals 2 to the something, so those somethings are equal. So now what do I do? Opposite of dividing by 2 is multiply by 2. And x is negative 18. Two to the exponent of negative 18 divided by 2, 1 over 512. So that's kind of a review of yesterday. That one that had a bit of a twist to it that we didn't quite see, but otherwise just kind of the same warm up, remembering what we started with, and you know, this is brand new, so going back over it a bit. This one's a little bit new. This one, but it's only one extra step and then it's the same. So we're just going to learn this extra step and then that's going to be it. This is what applications will look like. So our entire next unit is all about applications of exponential functions. I think you'll like it because the applications in exponential functions are really real world stuff. Stuff that you could imagine people actually doing and actually seeing it as being useful. Compared to things like throwing a ball off a bridge and when it hits the ground, why do I care about that? I mean, that is something that some people would, you know, use in their day-to-day life, but not many people. So, you know, there's a lot of other applications that we do in math class that, sure, they make sense. You can understand where they're coming from, but it's hard to connect to them as like real things. But in the next unit, I think you'll find that at least some of them, they really are real and they're interesting and they're powerful. So that's what this is going to look like when we're solving those. So the first step is, I talked about this. First of all, what's the base of the exponent part? 3? It's 3 to the x. The 2 is out front and being multiplied. It's not part of the base. It's just 3 to the x. And we can't write 54 as a power of 3. 3 squared is 9. 3 cubed is 27. 3 to the 4 is 81. So we skipped over 54. But also, you can't, this method that we're using doesn't work when there's other junk involved. That 2 is the other junk. It's in the way. We got to deal with it first before we can even do it. What do you think?
Do you just divide both sides by 2?
Very nice. We can divide both sides by 2. So when you have a number out front of the power part of the exponent part, we're going to divide by it. 54 divided by 2? 27. And what do you notice about 27? Yeah, it's a power of 3. So all these questions are going to be set up that they're going to work out that way. Or almost all of them, actually. I shouldn't say all, because we are going to do one other little thing that's different. So 27 is 3 cubed. So x is 3. So this time divide by 3. Sometimes the numbers are going to be small and you can do them in your head, but when we get into applications, we are going to get a lot of numbers that are not friendly. So once again, you got to remember, you got to know when to pull out your calculator. 24 divided by 3 though is 8. What power of 2 is 8? 2 to the, thank you, good. Try the first step of that one. So divide by 4, did you get 9? 36 divided by 4 is 9. The only difference with this one is the exponent is a fraction. We've already done that. 9 is 3 to the 2. I guess we just did one like this, so hopefully you're comfortable doing that. But again, when we have a number on the bottom, what do we do in that last step? Like you can see how when it's just an x like this one, the last step is just the answer. But when it's a fraction, it could be a little bit more confusing. It takes a little bit more getting used to. But what do we do?
Times 5.
Times 5. And I think I said this yesterday, you don't have to rewrite it twice. I always do because I like writing x equals 10 because that's kind of the point. But, you know, or you could just skip the 10 equals x or do whatever you want. This one's a bit different as well. So like I said, a big part of today is starting to get used to. So we're going to do some slightly harder ones, some slightly different ones. And I'm not so worried that you can do them right now, but it's to get us used to them for next unit, because we're going to be doing things like this in the next unit. What's the base? It's a half. So the base of a half is a very common base in exponential applications of exponential functions. It's a common base. So it's one special kind of question that we're going to look at. So that's why we're looking at this. The nice thing is, I don't really have to worry about the fact that it's a fraction. I can just look at the denominator of each, so the 64 and the 2. So 64 is 2 to the... Again, if you're not sure, you take a guess. 8. And notice that I'm not doing the fraction part because I only care about the denominator. Too big. Let's go smaller. Too big. Go smaller. Got it. Again, what was that? 4 seconds. Like, it's fast, right? So 1 over 2 to the 6 equals 1 over 2 to the x. Therefore, x is 6. One half to the 6, 1 over 64. So 0.5 is the same as a half, but it's written as a decimal, so that's something that could come up. And sometimes the other side is also a decimal. And unless you really work with this all the time, it's not likely that you're going to recognize 0.0625, which one that is. So same thing, we're just going to try some different ones. Anybody want to throw out a random number? 4. And it's going to, because of the mode that my calculator's in, it's going to give me a fraction, so I'm going to hit this button. Got it. Did you know that, or was that lucky?
No.
Lucky. It's awesome. Okay. But you would do the same thing where you would just, if you missed, then you would try again and you might go the wrong direction. Like decimals are a lot harder to work with. We're going to see that in the next couple of examples. Is the number getting bigger? Is it getting smaller? Am I getting closer to the answer or farther away? And there is going to be a few cases where there's more guess and check. That's a little bit harder than the ones we've done so far. But it's the same concept. Something that some people might start to confuse themselves a little bit is they might try to do 0.0625 to the exponent of something. No. We've got to stay with the same base. So it's 0. I don't know why that's in brackets. It's 0.5 to the x. So the base is 0.5. So you got to get 0.5 to what exponent, right, gives me 0.0625. So focusing on that same concept, that same method, and really getting used to it. The last two, we only have two more. And they have another little twist, but again, this is really just getting us prepped for next unit. I want you to see it today and think about it and start practicing a little bit, but we're going to revisit it again when we need to use it in the next unit. So the first step is divide by 500. Good. So I need my calculator for this.
Should we use a decimal?
Yep, definitely. We want the decimal. The reason why this one is different is it's not going to work out perfectly. It's not exact. But that's real world math. It's not like math class math where the numbers work out. Okay? And you get whole numbers, you get integers, and everything's just nice, and the answer's at the bottom of the page. Unfortunately, the real world's not like that. So in the real world, the numbers are messy, less friendly. You get decimals, they're not perfect. You get around things. So the method for this, what's my base going to be? Good, 1.1. So recognize the base. And I'm going to just guess. And what I can tell you, and I hope this is reassuring, I have no idea what that answer is. Like, I can't look at that and give a better guess than you can about what the answer might be. I don't do this often enough. I don't have this, but like, it's like working with these kinds of small decimals is not something that is easy to do in your head. So like, if you feel awkward because you have no idea what the answer might be, I feel that way too. Except I do have the answer beside me, so I know what it is. But otherwise, I wouldn't know what it was. So what do you think?
Decimal.
Not a decimal. We're going to stick with whole numbers. The exact answer, yes, would be a decimal. But we're going to go with whole numbers.
1.1 to the 10.
To the 10?
Yeah.
Okay. Tanner, what was your guess? 10? Did you already try it? Oh, you guys got it and already got it. What were you going to say?
I also did it.
Oh, you guys are supposed to just have a wild guess. So what would be your wild guess? Let's say we said 5. I'm going to pretend we don't know what the answer is. Is it 10? Yes. Let's say it was 5. I'm like, all right. How close is that? Not very close to 2.5. All right, 1.1 to the 20. I'm mimicking what this procedure might look like. I'd be curious to know what the three of you that found the answer, what you started with. Do you remember what you started with? 5? Oh, good.
I started with 520.
5. And then you started with 20? Interesting. Okay. Whoa, way too big. And this is what I'm saying. It's hard. It's hard to guess what the answer might be. So we're off by quite a bit both times. I don't know, maybe you go with 15. And you're just narrowing it down. Okay, it's not 5, it's not 15. Try the middle. I don't know, right? Like that's kind of how you might do it. And then something else that I often do, so that's very close, 2.59, and if you rounded that, it would be 4. What I always show, you'll see in the solutions and you'll see in my lessons, I'll do 1.1 to the 9, 1.1 to the 10. You don't have to write all these out, but you might do them. So this one is 2.594. To the 9 is 2.358. And to the 11 is 2.853. So then, yeah. Like, it's bang on, and generally speaking, I'm going to try to give you ones that you could have a lot of confidence that that's the right answer. But it's a bit trickier, right? And checking the one right before and the one right after just to make sure that somehow they're not closer, just because dealing with these decimals is not, we don't have that same confidence, right? Okay, one more. Same thing, divide by 16,000. So what's our base? Look at the exponent part, look at the base of that part, it's 0.8. What should we start with? Like, is 10 usually good, or 5 usually a good one to start with? Sure. Try 10. Nope. 8? Did we get closer or further away? We got further away. So go up. This is hard. This is a tricky thing. This number is bigger than 1. So when you make the exponent bigger, you make the number bigger. This base is less than 1. So when you make the exponent bigger, you make the result smaller. But trial and error, you don't have to worry too much about that. Just, whoops, I went the wrong way, so now I have to go bigger. So 0.8 to the, 15. Too big? 0.8 to the 13. Pretty close. To the 12. Oh, look at that. 0.06872, but very close. And I'm just going to check 11 to make sure that it's not closer, but it's not. So it's 12. Multiply both sides by 2. And we got it. And again, you can punch this into your calculator and check it. Watch, 16,000 times 0.8 to the exponent of 24 divided by 2, or just 12 if you're sort of thinking of it that way. Very, very close. Not going to be exact, but very, very close to 1100, right? Rounds to 1100.